So when we're looking at redox reactions and we want to determine what is being oxidized and what is being reduced and how many electrons are being transferred, we are going to be calculating our oxidation numbers or our oxidation state for each element within the reaction. We're going to focus first on atoms of each element as reactants and then see if they change when they become products. And so we'll be using our simplified rules for determining oxidation numbers. And we'll look at the same atom in both the reactants and the products. And it is important that we think about each atom individually. So we're not going to look at all of the atoms at once, but we're going to look at one atom of each element as a reactant and then see how it changes as a product. And so let's do a few examples here. So combustion reactions are a great example of redox reactions. In this reaction, we see that we have an elemental substance, oxygen, becoming a compound, in this case, both CO2 and water. So that's a clear sign that this is a redox reaction, going from an element to a compound or from a compound to an element. And so in determining what is being oxidized and what is being reduced in this reaction, we are going to want to calculate the oxidation numbers for each element as a reactant and a product. And so we'll start over here on the reactants and we will look at carbon. And so we'll see carbon here. We have carbon and hydrogen in the methane. Okay, and we'll determine an oxidation state for each of those. So hydrogen, as we know, is always going to be 1 in our compounds, plus 1, and therefore this carbon must have an oxidation state of -4 because there are 4 of these plus 1 hydrogens. When we look at oxygen here, it's an elemental substance, and so we know its oxidation state is 0. Now we're going to compare these to the oxidation states of the products. So now when we look at carbon dioxide, oxygen in compounds is going to have an oxidation state of -2, and there are 2 of them. So that means this carbon is now a +4. So carbon has gone from a -4 to a +4. Oxygen has gone from 0 to -2, and it is -2 both in carbon dioxide and in water, and hydrogen remains as +1. So hydrogen does not change its oxidation state, but carbon goes from -4 to +4, so we're going to say carbon is oxidized. And oxygen is going from, so that's our carbon. Oxygen is going from 0 to -2. So oxygen is being reduced in this reaction. Okay. So again, we're looking at a single atom of each element. Notice that even though there are 2 oxygen atoms in a carbon dioxide, each oxygen atom has a charge of -2. And 2 of them are going from 0 to -2, so we have a total of 4 electrons being transferred here and 4 more being transferred there. So going from a -4 to a +4, we're actually transferring 8 moles of electrons for every 1 mole of carbon here. So here's another couple of examples. So we're going to look at each element, each element in our compound. So in this example, we have sulfur and oxygen. And then over here, we have sulfur and oxygen, and then oxygen over here in O2. Now, when we look at the sulfur, again, we're going to recognize that it's got oxygen in the chemical formula, and whenever we're using oxygen in a compound, we're going to call it -2, and there are 3 of them Therefore, we have a total of -6 charge or -6 oxidation states. So this must be a +6 for sulfur. Now, when we look at our products, oxygen in sulfur dioxide is still -2. That means sulfur is only +4. And in our molecular oxygen, it is, of course, 0. So in this case, we're looking at what is being oxidized is the compound in which the oxidation number increases. So in that case, it's going to be oxygen going from a -2 to a 0. So it's becoming less negative or more positive. So oxygen is being oxidized, and it is the sulfur that is decreasing its oxidation state. So sulfur is being reduced. It is becoming less positive by gaining electrons. And one more quick example just to make sure we've got it. In this case, we have nitrogen and we have hydrogen, and both of these are elemental compounds. So they both are substances. So they have a 0 oxidation state. And now we're going to look at these compounds in ammonia. Hydrogen in ammonia is going to be +1, and there are 3 of them. Therefore, nitrogen is -3. And so the element that is increasing its oxidation number is losing electrons, and so that will be hydrogen is going from 0 to +1. So we say that hydrogen is being oxidized, and nitrogen is being reduced. Zero to -3 for the nitrogen, 0 to +1 for the oxygen. So in determining what is being oxidized and what is being reduced, we are going to look at the oxidation numbers for all of the individual atoms in both the reactants and the products. And if the oxidation number decreases, that means that that substance, that element is being reduced. If the oxidation number increases, that substance is being oxidized.